this number L. What did you sketch for that first one? What shape is that? That's your parabola, right? Your U shape, your parabola. So you should have drawn a little parabola at the origin like this. Okay?
Do you have an extra one? I can't find it.
I don't know if there's any extras back there or not. All right, y equals e to the x. What did you draw on that one? I hope you drew an asymptote at 0, a dot at 0, 1, and then a curve that looks like that. Right? And then y equals sine x. This one, a little bit picky on this. We have to start at the origin and make a hill, and then a valley. And that's the way the thing goes. Okay? Now, write the name. So what do we have in A? 2A. That is the
Cubing.
cubing. And what do we have in B?
Logistic.
Logistic, good. And C.
Absolute.
Absolute value. All right. Now we're going to write the equation. So for this section, start out with y equals y equals y equals. This is going to be your equation. So y equals something. What's that first one? 1 over x. That's your reciprocal function. 1 over x. How about the second one? Square root x. That's exactly right. And the last one.
Y equals X.
Y equals x. That's your linear or your identity function. Okay, now here comes the hard part. There's 3 of them that we
Squaring.
don't have on the board yet.
Squaring? No. Is it squaring?
Cosine.
Squares right here.
Cosine.
We don't have a cosine up here. We don't have a greatest integer up here.
Logarithm.
And we don't have a logarithm up here? Nope, we don't. So remember, now I wrote the names because that's how you said it to me. But remember, if you can think of the equation or if you can think of the picture, those are good too. For this section, any way you can express it is fine. All right? Well, guess what? There's another one called E. So here we go. What does x cubed look like? X cubed is the squiggly one, right?
Yeah.
So remember, I'm kind of picky about that shape. Make sure you have that shape. Who remembers how I gave you a hint? I'm drawing it. Parabola down and parabola up and then erase half of each. And that will give you that exact right picture. All right? What about L and X? What does L and X look like? It has an asymptote here, a point at 1, 0, and comes up and out. You know which ones you really have to study. And then C, y equals x. Oh, I hope you don't have to study that one. Y equals x is your linear, right? That one's easy. Uh-oh, I made a mistake on this one.
Like 50 squared. I know the next one.
You're gonna have 4 that have been used on this one. All right, What's A?
Quadratic.
Quadratic, or,
And
what's the other name?
I forget the other
You could call it squaring. One name is enough. But some of you maybe learned it squaring, some learned it quadratic. All right, how about the second one?
Linear.
That's linear or identity. So that's my mistake, because I got that twice. That means it'll be 4 now. And what's the last
Cosine.
one?
Cosine X.
Cosine, yep, that's your cosine. How do we know it's the cosine and not the sine?
This starts at,
Because
1,
it
0.
starts up here instead of at the origin. Sine starts at the origin. All right, number 3, these are all equations. Y equals
1 over X.
1 over x, that's your reciprocal function.
I'm down for this next. This is a,
E to the x is exponential. And remember on our quiz, let's say you know that's the exponential, but you can't remember the equation. Write down exponential and you'll get half credit. All right? So don't leave it blank. Write down anything you know about it.
oh, I forget. Greatest value.
Greatest integer. And
Yeah,
what
I
is
forget what the,
equation?
I forget what the equation.
Y.
You can either write this, int x, that's
Oh,
fine.
just that, oh.
Or we can use the brackets. That's the notation that's used sometimes. Alright? And then what's left? There's actually 4 left. Which 4 are not up here? We don't have a sign up here. I heard somebody say square root. I don't think that's up here.
Logarithm.
Logarithm's right here.
Logistics.
Logistic is not up here.
It was one of the L's, I believe.
That's not good enough for points, you gotta have something that looks like
Yeah,
that.
absolute value.
That absolute value. This wasn't a trick question, it was a mistake. I included the linear twice, so that meant I only used 8 functions, and so that's why they're, alright? Last practice. By the way, these are all in Canvas. Can you put them in your ability to practice them as many times as you want? Yep. Can you print them off and do it as many times as you want? Yep. If you talk nice to the boys over there, they made a Quizlet. Right? You're not getting it, sorry. All right, here we go. Last one.
I get credit.
The only reason you will not do well on this is if you don't practice. So,
Is 1.3 due to
practice. All right, here we go. What does square root look like? Dot at the origin?
Oh, goes right
Up and out.
Yep.
What
this
does 1 over x look like?
That's the,
It's like this.
Asymptote, this piece, and this piece. It's the only one, I think, that's in 2 pieces. And what's that?
That's app, or,
Greatest. This is the hard one, so you're gonna put a dot at the origin, a solid dot at the origin, and it'll over 1, open dot. Step up, solid dot, over 1, open dot. Step up, solid dot. This is how you're going to draw it. You need to draw 4 or 5 steps.
Does it have to be on the
There are
bottom
a
too?
couple that are challenging. That's one of them. Right? All right, here we go. Write the name. What do we got there?
Cosine.
That's fine. How do I know
Original
It
sin.
starts at the.
Goes to the origin.
Original sin.
If it goes through the origin, it's a sign. How about B, the name?
That'd be
Not logistic.
logo.
That's your natural logarithm or your logarithm. You can write just logarithm or you can write natural logarithm. Either one's fine.
Nope. Yes, it
Exponential.
And the last one's exponential. Spelling needs to be close. You have practiced and written these enough that you ought to be in the ballpark. All right, now on with the equations. What do I got that first one? Y equals
is. Absolutely.
absolute value. Y equals x cubed.
Yep.
Y equals,
X.
all righty. I didn't make any mistakes on this one, so you have 3 leftovers.
Yeah, cosine. Then.
Cosine is left over.
Then.
Logistics.
Logistic is left over.
I don't know.
Oh, it's quadratic.
Yep, I don't see any squares up here, do you? Any parabolas? So the quadratic, or the square.
That was I didn't even do that.
Okay? This is something I know parents always want to help their kids succeed in school. So this is something your parents can do flashcards with you. Think about the quality time you could have with mom or dad studying your
Paul.
BFFs.
Paul Lee.
Paul.
Paul Lee's an awesome person. Let's be nice to Paul Lee. It's not his fault. He's got sons like this, right? All right, let's get out our notes now, and let's continue on with what we've been talking about. So we are getting ready to start 1.4. Yesterday we finished 1.3, so that is due tomorrow. We're getting ready to start 1.4, but before we do, I want you to find page 9A of your notes. Page 9A. Little review here. We gotta keep this stuff fresh in our mind. All right, domain questions. What is the domain? So this was on the last quiz you took. I just turned those back. Some of you did great, some of you didn't do so great. What do I think about when I look at a problem that talks about domain? What goes through my mind, Zion?
Greater than or equal to.
0.
So whatever is under the radical is greater than or equal to 0. So x plus 1 is greater than or equal to 0. 2x minus 5 greater than or equal to 0. If it is under a radical, it has to be greater than or equal to 0. Then I solve. X is greater than or equal to -1. X is greater than or equal to 5/2. Now, that problem is done. Would you agree? This one is not. Why is this one not done yet? Because it not only has a radical, it has a denominator, right? So this one I'm done with. This one, my domain is from 5/2 on. That one's done. This one is not done. Because this one has a denominator, and denominators cannot equal 0. So I gotta be bigger than -1, that is true. But I also cannot be 2. your answer? Okay, that's good enough. If you wanna write that as an interval, you can, but it's tricky, so it's probably best that you just leave it. Two parties are perfectly okay. Now, what about this middle one here? What's the domain there? Negative infinity to infinity.
Oh,
How
yeah, 'cause there's
quickly
no
you guys
radical.
forget. If
No,
there's
there's
no
no radical.
denominator and there's no radical, then what's your domain? Everything, right? Everything. Number 2, find the horizontal, vertical, asymptotes, and holes. All right, let's look at the first one. As you need to notice, we're gonna have a test after 1.4. We're starting 1.4 today. So you need to know this stuff. All right, I need a horizontal and a vertical asymptote. How do I find either one of those things? What? So, if I box in or circle my x's, this is gonna be my horizontal asymptote.
Yep.
2x over 1x is 2, so my horizontal asymptote is at y equals 2. Where does my vertical come from? The denominator. So what do you know? X plus 5 can't be 0, so x can't be negative 5. Would you agree with that?
Yes, ma'am.
That means you have a vertical asymptote at negative 5. Vertical asymptotes are cannot be's. So when you tell me x cannot be negative 5, that means I have a vertical asymptote at negative 5. All right, B, oh my. What in the world are we gonna do with this thing? Come on. Right?
Would it be x minus 1, x plus 1 at the bottom?
He's gonna factor it. So he's factored bottom, he's got that one done. What about the top?
X minus 4, X minus 4,
X minus 5, x plus 1. Remember, Zion and everybody else, they have to multiply to give me 5. I gotta have a 5 and a 1. Uh-oh,
Yeah, and then
what do we notice?
cancels.
We can cancel. And when you cancel, you have a hole. So we're gonna have a hole where x is negative 1. Because that is the factor that I canceled out. How do I find the y part? The x part is from what I canceled out. How do I find y? Plug it in right here. So if I plug in negative 1, I have negative 1 minus 5, which is negative 6, and negative 1 minus 1, which is negative 2. So that boils down to 3. What about a vertical asymptote? Where do those come from again? Where do the verticals come from? The denominator. So x minus 1 can't be 0, so x can't be 1. So where's my vertical asymptote? X equals 1. Yep, x equals 1. How about my horizontal? Where does that come from? come from over here.
X's.
Box them in. You have x over x, which is 1. X over x. Anything over itself is just going to be 1. So my horizontal asymptote is y equals 1. Remember, if you're getting your x's and y's mixed up, when you draw a horizontal line, it crosses the y-axis. It's a y equals. Vertical lines are x equals. So imagine drawing it, or go ahead and draw it, and get your letter. All right. C. What are we going to do with letter C? Nothing on the top. What about the bottom?
X minus 2, x plus 2.
Yep. Now, does anything cancel?
No.
That means this problem will have no holes. That's okay, fine, none, no holes. However, it's gonna have 2 vertical asymptotes. One of them is at 2, and one of them is at -2. This was the original problem. To find my horizontal asymptote, what am I supposed to do? This, right? But what's the rule for that?
Oh, it's.
Whatever you box in, they have to be the same?
Yeah.
So you can't, don't do this. That is wrong. Because you can't box an x and an x squared. So we're gonna have to box x squared. Well, how many x squareds do I have on the top?
1.
X squareds?
No.
I don't have any x squareds on the top, but I have 1 on the bottom. So my horizontal asymptote is 0 over 1, which is 0.
I thought it was undefined. When's the one when it's undefined?
You can't divide by 0.
When it's 1 over 0?
Do we have to show our work for that? Because on the notes, you just said that there's a rule, like,
Yep.
the top is left.
Yep, actually listen to me. It will always be true that when the power on top is smaller, when the power on top is smaller, the asymptote will be at 0 every time. And when the power on top is bigger, there will be no horizontal asymptote ever. So you can memorize that. Always true. All right, so having said that, I'm not gonna write D down. Where is the horizontal asymptote? It doesn't have one. Because the power on top is bigger. Where is the vertical asymptote? X equals -1. All right, let's get to the right spot in our notes now, and let's jump in. And that was all review. We have a quiz BFF next time we gather. We got 1.3 homework due tomorrow. And we're getting ready to finish up 1.4. All right, so at the top of the page, we have some random functions. These are not special. I just sat down and made them up. I guess that one's kind of special because that's a BFF. But these are just a bunch of functions. And we're going to do a bunch of stuff. So f of x plus g of x. Couldn't be any easier. What do you think you're going to do? You're gonna add them together.
Yeah.
So F is x plus 2, G is x squared. I'm gonna put it in the right order, and that is my answer. That's what I get when I add F and G together. Done. 2f of x. Any guess on what that might be? What'd you say, Lila? Yeah, it's 2 times the f function, so that's 2x plus 4. G of x minus h of x.
X squared
So that's g, which is x squared,
negative 2x.
minus negative 2x plus 5.
Yeah.
And then when I distribute, that's gonna be x squared plus 2x minus 5.
Yeah.
And that's it, you're done. The question said, what do I get when I do this subtraction? Well, that's what I get. We're not solving it, we're not doing the quadratic formula, we're not factoring it, we're stopping. G minus h, that's what we get. F of x times g of x. Well, what do you think that means?
X plus 2 times x squared, which is x to the third.
Times x squared.
Yeah.
So x cubed plus 2x squared. Oh my gosh, isn't this like so easy?
Yeah.
Yeah.
F of x divided by g of x. So x plus 2 over x squared. Please, do not cancel. Don't cancel unless you can factor. When you factor something out, then you can cancel it out. But don't just say, oh, there's x's. Yep, can't cancel. That's it, that's your answer. Alright, now, we're gonna go back to all the problems we just did, which I have them all listed here. And we're gonna find the domain of the answer. So what's the domain of this guy? What?
Everything?
Everything. How do we express everything?
Negative to infinity.
Yep. Negative infinity to infinity. Why is it negative infinity to infinity? There's no denominator and there's no radical. Alright, what about this one? What's the domain of that one? Everything. One more time, boys and girls. No denominator, no radical. All good. How about this one? Negative infinity to infinity. This is getting boring, but enjoy it. How about number 4? Same thing. How about the last one? Uh-oh.
Denominator.
Has a denominator.
So
Can't be equal to
0.
0. Can't be 0. So your domain is everything except 0. You are allowed to leave it that way. If you want to write it this way, you can, but it's more writing, but that is the official interval answer. Alright, now, these are the same functions. But this is different. Guys, that does not mean multiply. Don't be multiplying. This is not a multiplication problem. This says f of g of 2. That's how I read that. So if I were talking to somebody on the phone, I would say f of g of 2. That's what that means. Do you remember how to calculate that?
But is it of multiplication?
It's not multiplication.
Equals?
It's called composition. This is function composition. First thing we do is start right here. So we're going to figure out what g of 2 is. Order of operations says start inside first, right? Always?
Yep.
That's what we're doing. We're starting inside. So what's g of 2? Here's your g function. What's g of 2? Well, it's not x squared. It would be 2 squared, which is 4. Remember, when you evaluate a function, g of 2, you put in 2. So 2 squared is 4. Don't even look at me like that. You did it freshman year and you did it last year. Evaluating functions. So this is g of 2, right here, g of 2 is 4. So this is 4. So now it says find f of 4. So f of 4 would be what?
4x.
6.
Take out the x
Or
and put in 4.
6.
So we get 6. And that's the answer to the problem. So when we do a composition, we start inside, so we put 2 into g, and we got 4. Then we take that 4 and put it into f, and we got 6. Now, that is exactly the same as this. So problem H and problem G are exactly the same thing, just written differently. That little circle, it's like a degree mark, like we write 32 degrees, it's like a degree mark. That means of, that's composition. So f of g of 2. These two things mean exactly the same thing. So don't be confused. They're identical. All right. What does this mean? Can you read that to me? This is letter I. Can you read that to me? What does that mean? G of f of 2. So what do I do first?
Inside.
I plug 2 into f. Right?
Yep.
And what do I get when I
4.
plug 2 into f?
4.
4. Now I'm going to take that 4, this equals 4. Now I'm going to take that 4 and plug it into g. G of 4 means plug 4 into g. So what do I get when I plug 4?
16.
I get 16. And that's the answer to the problem. So it's a two-step problem. Whatever number you're starting with, plug it into your first function, get an answer, and then plug that answer into your second function. All right, you try J. You try h of f of negative 1. You try that. I'm sorry, guys. He said you guys didn't cover composition last year, so that's why they're all staring at me blankly. Alright, so we'll do a little extra practice. So let's see how you did with this one. H of F of -1. What did you do first?
Plug -1.
Plug -1 into
F.
F. So when you plug -1 into F, you get -1 plus 2, which is 1. Alright?
Yep.
Then we take the 1, that 1 right there, and plug it into H. So H of 1 is 3. And that's the answer to the problem.
It's like absolute value bars or no?
These right here?
No, like the actual like.
This?
Yeah, those.
No, those are brackets.
Oh, there's okay.
They're just notation.
So if it like was a negative, it wouldn't be positive. Okay.
Alright, let's try the next one. Remember, those little open circles mean the same thing as the parentheses. So, this problem could be written like this, okay? This means exactly the same thing, so don't let the letters or the symbols bother you. We got 3 of them. Where do we start?
H.
With H. Always start inside, or if they're not really inside, start with the one closest to the number. So we start with H of 1. So here we go. What is H of 1? 3. Remember, you're taking out the X and putting in 1. There are no X's in your answer to this problem. Okay? Now, what do I do with the 3?
Plug it into.
Plug it into
G.
G. So I plug 1 into H, got an answer. Now I'm going to take that answer and plug it into G. So G of 3 is 3 squared, which is 9. But I'm not done.
Plus
Because
2.
now I have to take the 9 and plug it into
F.
F.
Which is just plus 2.
So F of 9 will be 11.
Now it's starting to flip.
And now we're done. When you run out of letters, you're done. Alright, with your partner, I don't know if there's room on, yeah, you've got room, like you're on edge. We'll use the same functions. With your partner, would you find H of F of 10? So with your partner, find H of F of 10.
Where'd you get the 10 from? Wait, where'd you get the 10 from? Just random.
Just making up a couple extra problems. So these aren't on there, these are actually, we're using the same functions. So we're over here in margin. Alright, anybody have an answer to this one? We're gonna check it together.
19.
What?
Negative.
Negative 19? Right, here's several of those. Let's see if that's right. F of 10. F of 10 is 12. Then I take the 12 and plug it into H. So I have negative 2 times 12 plus 5. You are exactly right. Good job. Negative 19. Negative 19. All right, and here's a three-parter. Try this one with your partner. Are you telling me the answer?
No, I was just.
What is it? 3? She is back there. She says the answer's 3. Let's see if she's right. Anybody else get 3? Oh, a bunch of you did? Good. All right, where do we start? Come on, if you are lost, get your eyes focused up here. Let's go. Where do we start?
With the F.
Negative 1 in for F. And that means replace the X with negative 1. So we have negative 1 plus 2, which is 1. Now, take the 1 and plug it into the next letter, which is B. So, 1 squared is also 1. And then take that 1 and plug it into H. Right here, put 1 in there. So that's negative 2 plus 5, that is indeed 3. Good job. Okay?
Yep.
All right. One more thing before we look at the next one. Does the order I do it matter? In other words, would F of G of 7 be equal to G of F of 7? All right, let's check that out. Does the order matter? That's my question. I don't know.
Most definitely.
Can I do it in either order? I heard somebody say something. What'd you say, Brian?
I think it does matter.
It definitely, you said definitely.
Yeah.
And you are right, it definitely does matter. Let's check out his thing. So what do I do first here?
7 times.
G of 7. So G of 7 would be
X squared.
49.
Yeah.
Remember, when you say G of 7, you mean take out the X and put in 7. So 49. Then we'll take the 49 and put it into F.
51.
And that's 49 plus 2 or 51. So when I do F of G of 7, I get 51. Now what if I do F first? Well, what's F of 7? 9.
Yeah.
And then I'm going to take the 9 and put it
81.
into
81.
G, and I get 81.
Does matter.
Notice I got 2 different answers. So it does matter. Make sure you are going this way when you do your letters. Okay? All right, let's look at one more problem. Did we do K? Yeah.
Yep.
Right? So we have L. Anybody see anything different about L?
Like, is there no variable?
Well, there is a variable,
there's
there is no number.
There's no number, yeah.
There's no number. So if this were a 2, we would put 2 into G, get an answer, and then put that answer into F.
Yeah.
When you do the same thing, you're just not going to get a nice neat answer.
Oh,
So we're going to start with G of X.
It'd be X
Yes,
squared.
Exactly. G of X is
X squared.
X squared. Then I will take that x squared and plug it into f. Now remember, all that means is f of x squared will be x squared plus 2. When you plug something into a function, you take out the x and put that something in. So since g of x was x squared, I'm going to take that x squared and plug it in right there in f. So that's the answer to the question. Okay? We'll pick up there tomorrow. Or whenever I see
I was like, I'm turning it.